Rust makes it easy for us to convert data into strings. We can convert any data type into a string, and it's super simple. They make it available a toString trait for any other type that you can convert into a string, which is really neat the way they do this rather than doing it directly, because you could, if you wanted to, you can implement your own toString method. You don't have to. You could do it with the format display instead. All you have to do is define the trait, and it automatically adds a toString into your code, that's so cool. So I've got a struct here, circle with a radius. All I have to do is implement the display trait for my circle structure. So I have my format, and then I've got a formatter buffer reference returning a result, and then we just write directly as we need to using the writeToBuffer, which is our F, right? Our formatter buffer, circle radius. And this will convert that data type of my circle, my struct, into a string. And there it goes. It's really simple. I like this. Okay, so we've got our instance of a circle. We define it with radius 6. We're printing the circle itself with a .toString. Oh, wait, hold on. Is this the same? It's the same as this. Are these two things the same? Am I gonna see double here? They are. They are the same. I mean, it's kind of neat that that's there. I suppose, so for example, if you did want to like assign this to a variable, we could do something like that, where we've defined a variable. And now basically we've created this, a toString implementation without having to write our own toString method. So then we can use this later on later in our application. So I can say print circle info, and let's see if that works here. There we go. So we've captured it as a string in a variable. That's pretty cool. I really like that. Very often we'll find ourselves, most of the time, needing to do this one thing. We have to convert a string input into a number. Usually we've captured that data from user input, and that is going to be in a string format, a series of characters. And often we want to capture numerical values from user input. And this can even be through data exchange, like over the wire, right? That data is often transmitted as a string or as a string of ASCII characters, Unicode characters. We need to convert that into the actual number itself so we can do some math operations or store it as the data type of a number. So it's the most common scenario is parsing a string into a number. Since it's so common, it is native into Rust. Rust will provide this capability for you automatically. You can parse a string, say user supplied the number 5, you just say .parse unwrap. This is similar to a try from that we took a look at over here. It's already implemented for us, but basically we wanted to convert a string, in this case, so it would be a string, right? So Rust has already implemented this for us in this case, and they did something like this, something along those lines. And so this is like a nice little concise way here to do that. Note that of course this can fail if there's, wait, let's try it. Let's go through a failure scenario really quick. Okay, let's say we've got the number 5, right? It prints out 5. If we did some random stuff, but the number's right here, but the parse is probably not going to capture that. So we get a panic. Oh, we called unwrap, which is looking for an OK, but it returned an error. It found invalid data. So we could throw a match around this, looking for an OK. So now if we run this here using a match statement on our crazy user input data, we can basically capture a default number in case the user supplied information. We could do more than just a default, right? We could do throw an error back to the user saying, hey, that's not a number. Or we could go deeper and then we can figure out, maybe intuit, did you mean 5, right? We could see that there's really a number here. There's just extra information. We could figure out a way to parse through that. So there's a lot of things that we can do. I kind of like that. This is typically what you'd want to do when you're using a parse, because you do need to look for those error case scenarios. All right, now I want to take a look at what's this turbo parsing? What's going on with this turbo parsing stuff here? In this turbo parsed, in this case, it just appears to be just a different way to write it. So it's the same. It needs to know what we're parsing into, right? We need to know what we're converting from the string into what. Both cases have this information. Both lines have this information. So it's just a different way to write it. And it says here that we just use the parse function in either range for the type inference using this approach, or you can specify a parsing using the turbo fish syntax. That kind of does look like a fish a little bit right there. It's got a few extra colons, these greater than, less than symbols, and the type that we're looking for. So it's a few extra, I was just taking, it looks like there's just a few extra symbols, 3 additional symbols required with the turbofish syntax. You're looking to reduce code. This is a little more concise to use this approach. These are the same as far as I can tell. When would you use one syntax over the other? I'm trying to think of one. Doesn't seem like there's got to be a reason. We'll find out eventually. And now we've parsed our string numbers into actual numbers. We can do some math on those numbers and then return the result. So 5 plus 10 is 15. And we did it. This code right here, the code that we're looking on the screen, is one of the most common code that we'll probably see in many applications, if not most applications. We'll see needing to parse string data into some other kind of data, usually a number.